Hello, and welcome to the first lesson in your AP pre-calculus journey. You guys will see that this year, while we do learn some new stuff that we have not talked about in the past, you'll also see that this is quite a big review of last year's course. And last year, if you remember, we talked a lot about functions. And if you don't remember what a function is, let me remind you. It is a mathematical relation where every input has one and only one output, meaning for every x value, there can only be one y value. For every input, there is only one output. For every domain value, there is only one range value. Also, in this course, we are going to see some functions that we have never really seen before. We're used to being able to do a vertical line test to see if something was a function, but we're going to see later on in this subject that that doesn't always work. It works for polynomial functions, which is all that we ever worked with in Algebra 2, but we're going to be working with some weird functions later on in this course. So let's get away from using the vertical line test and just use our definition of for every input, there is only one output. All right, let's talk about something that we haven't talked about in Algebra 2. Let's talk about a function being positive or negative. And what does that mean? So remember, in a function, we have an input and we have an output. We are really more concerned with the output of a function and where it is, right? So the input, which is the independent variable, because the x can be whatever we want it to be. The y, however, depends on what that x was. So y would be called the dependent variable, right? Also, throughout this course, you'll hear me call the y value the height, right? Really, we're trying to figure out when I'm asking, is the function positive or negative at a given point? What is the height? Where is it? What quadrant is it in? All those kind of things mean kind of the same thing. So if you're above the x-axis in quadrants 1 or 2, you would be considered positive. So where all this is in the green, that function is positive. All this stuff in the red down here would be negative. So what does that mean? That means if I have a graph that looks like this, and everything is in the above the x-axis, that would be a totally positive function. And conversely, if it was down here, that would be a negative function. Okay? In AP Precalculus, we're going to be seeing functions written in many different ways. We're going to see the old normal graphs, our equations. We're going to work with some tables, and then we're going to see some verbal ones, which is basically just word problems. I know that we all love word problems. It's that last one that we're going to have to work on, and we're going to have a lot of time to practice these things. But words are very important, and we have to be able to see and identify the important information in a verbal representation of a function and then construct an equivalent representation in one of the other forms. All right, take a second to read this word problem here and look at our answers and actually take a look at the graphs. So our axis on these graphs, by the way, that would be the first quadrant because this is a real world problem. You can't have negative time or negative height. But look at our x-axis. Is it the time, and the y-axis is the height. So we're pouring water into this vase at a constant rate. That's kind of important. And we want to know which of these would show the height of the water in the thing as it starts filling up at a constant rate. So if we look at a nice linear height, that would be if we had a cylinder that looked like this, where they're just normal, And if I started pouring it into water into that at a constant rate, it would fill up at a constant height. So these do not look the same. So we're going to go ahead and cross out A. We know it's not A. So what are these other ones telling us? So here in B, it says, okay, we're going to start out filling up kind of slow, get really fast. It goes up really fast, and then it starts slowing down again. This one here goes, ooh, we're going to fill up really fast, really fast. And for some reason, we start losing height. That doesn't make sense to me. And then we start going back up. Because this one talks about losing height, we're going to cross that one out. And then we're down to D. Starts out a little bit fast, then it gets slow, and then it gets fast again. So let's think about this in the real world. When I start pouring water in, it's going to kind of go up kind of quick. And then because it gets wider here, it slows down. But then when I get up here, if you've ever filled up a water bottle, you know that you got to be careful when you get up towards the spout, because up here it goes in real fast and it just pops out the top. So at the top of this vase, it's going to fill up really fast. Which one does that? Well, this guy here says we start slowing down. This guy here says we start going a little bit faster. So the answer is D. All right, before we talk too much about this slide, I need to remind you from last year how we used to write a function in function notation. I'm just going to make up a function here, right? If you remember, I told you that this guy right here is the exact same thing as a y value, okay? So you're going to see some notation throughout this class that might be a little bit new to you, might be a little bit strange or foreign. So we got to kind of get used to it in the beginning. So if you look down here, it says if A is less than B, then f of A is less than f of B. What that really means is the x value, which we'll call A, and an x value, which we'll call B, when I input it into the function, I get f of A, or a y value, an output. If I put B in, I get f of B, or an output, or a y value, right? So what is all this saying? It says is if I move from left to right, because A is less than B, we read from left to right, if the y value is less than the next y value, we must be increasing, right? Well, that's a really long way to say if I move from left to right on my graph, if I'm going uphill, it's increasing. We've talked about this before, guys. All right. Same here. If I move from left to right on my graph, if I'm going downhill, I'm decreasing, right? So nothing new from last year. These next two parts, though, we've never talked about this. We're talking about concavity, right? And you see this word right here, rate of change. We're going to be talking about that a lot this year. It just means slope, right? If the slope is increasing. And so as we have points that go along this graph, right? If the slope, what does that mean, the slope? So meaning if we draw a line that only touches one of those points as we're doing, we call those tangent lines, by the way. What's happening to my slope? Well, the slopes are starting off negative and slowly becoming positive. That means they have to be increasing, right? If your slope, if your rate of change is changing throughout the graph, we have concavity, okay? So the rule is if it's increasing, if your slopes are getting bigger, you are concave up. And if your slopes are getting smaller, look at this one. So we got points. I'll just pick a couple points here. We're starting off with a really positive slope, right? And as I get up here, it actually becomes 0 and then turns to negative slopes, which means I went from positive to negative. I must be decreasing. And if your rate of change, if your slope is decreasing, you are concave down. All right. So another way you could think about this, if I wanted to fill this with water, would the water stay? If the water stays, you're concave up. If the water falls out, you're concave down. Some teachers might say, hey, if it looks like a smiley face, you're concave up. If it looks like a frowny face, you're concave down. Okay? Okay, here we have another word problem, and it's asking us, where is this graph increasing? Where does the f values increase, meaning the y values? Where does the height increase? All right, and they're telling us that we are starting from 0 and going to 9. Just remember, interval notation, it would look like this, 0 to 9. I use brackets because those numbers are included. You'll see that they're closed circles at 0 and 9. All right, so let's look at our graph. So basically, we're going to start here at the far left at 0, and we're going to walk along the graph. If we're going uphill, it's increasing. If we're going downhill, it's decreasing, right? So what do I have here? I have uphill here and here, right? So how am I going to show those intervals? We could use inequality notation, but we're in a college class now, so we're going to use interval notation, okay? So how can I show the interval from this point 0 on the x-axis to this point 3? We don't want the y values. We don't really care about the y values. We care that they were increasing there, but we want to know where is it increasing, meaning what are the x values? Between what two x values is it increasing? So I'm going to put -2 to 3. And I don't really want you to worry too much about what we're going to use as far as, do I use a bracket? Do I use a parenthesis? Don't freak out about that. I will tell you that normally at a single point, you can't be increasing or decreasing. So the normal would be to use parentheses. But for the most part, this would be a multiple choice question, and they're not going to be jerks and put this as one of their answers either. Okay, or this, or that. They're not going to do weird things like this to try and trick you, okay? But for our purposes, when it's a free response question, let's go ahead and use the parentheses, okay? Because we're not including those last points as part of increasing or decreasing. And let's not forget, we have a second part, so we're going to union that with 7 to 9, okay? Now, this is kind of a newer thing. I brought that up last year in Algebra 2, but you may not remember. Again, this is one of those things, it's not that big a deal. They're not going to take off if you don't put that. But this is the upper level math way of writing this problem. Okay, on this page, I want you to pay very close attention to this right here. Rate of change. We are going to see that over and over and over again, probably in every single unit. We're going to talk about rate of change. And rate of change sounds really fancy, but you know what the rate of change is? We can change that to slope. If you don't want to write rate of change, you can cross it out and call it slope. Some people will do this. They'll put ROC, rate of change. If you ever see it written like that, if you don't like it, cross it out, put slope, because that's all it means, okay? So when we get down here, I want you to look at these two things right here. They want to state when f is increasing or state when the rate of change is increasing. They look really close. They mean two totally different things. We've got to be really careful with words. Words have meanings, okay? They matter. You'll see the little thing over here. Words matter, okay? So we got to be careful. What is this saying? Well, when it says f is increasing, we're just talking about the y value or the height, right? So if I look at this thing right here, what is the f doing? What is the height doing? Well, it's decreasing. As I'm moving from left to right, I'm getting lower and lower on the graph. But what is the slope doing? Remember, rate of change is the slope. So look over here to the side here. If I give you this slope, and I said, hey, what would you say that slope is? Somebody might say, oh, it's 1. M equals 1, right? What if I gave you this slope? Well, I don't know. That might be m equals 6. That slope got bigger, right? But if I went this way, and I go, oh, that might be n equals negative 1/3. Well, that slope got smaller, okay? So that's what it's asking in this second one. What is happening to the slope? And what we mean by slope is if I pick a point here and I draw a straight line that only hits that point, right? That would be a very small slope. Like we would say m equals, I don't know, like -6 there. But if I picked another point down here and I drew a line where it only touched that point, we call that a tangent line, by the way, that's getting a little bit less steep, right? And I come down here, heck, that line might be m equals -1/5. So what is happening to my slope? My slope is actually increasing, right? It's getting bigger as far as the value goes. So if slope is increasing or decreasing, remember we have concavity and this slope is increasing. So part of our notes from a couple seconds ago was if slope is increasing, it is concave up. Like if you wanted to extend this, I know that this slope is actually going to end up being shallowed out right there, but let's pretend that it did this. That would be increasing all the way around, and then we have our smiley face, right? Same over here. Let's talk about what is going on with the height. What is F doing? So starting here, that's our height. It's really small and it starts going up. The height is getting bigger and bigger and bigger, right? I know that it's always in the negative, so this would be a negative function. However, the height is actually getting bigger, right? What about the slope? Well, our slope is going up, going, uh-oh, that slope is starting to get smaller, right? And if we continue this, let's pretend that it doesn't shallow out. Like what if it did something like that? And we put our face up here. We'd have the big frowny face. That is concave down, okay? Here we just have a quick graphical representation of concave up and concave down. If you can hold water in it, it's concave up. If the water spills out, it's concave down. All right. Before we talk about this, I want you to notice down here what this little note says. FRQ3, free response question number 3, is going to be just like this question. So let's make sure that we get this one down. All right, so here we go. The graph of h of t. All right, so this graph right here, h of t. We have the dashed midline. It's showing a couple cycles. We'll get to that at some point. But I want you to notice that, look, hey, this is the x-axis because we have a -3, 0, and a 3, 0. And remember, whenever your y is 0, you're on the x-axis, right? All right, so h of t, that's the actual graph. We have two coordinates that we want to talk about. We want to talk about coordinate f and coordinate g. So t sub 1 and t sub 2, those are your inputs. So that's your -6, and your -3. It's asking on the interval between that -6 and -3, which of the following is true? Uh-oh, we got to be careful because it could be false sometimes. Remember, words matter. Make sure you're reading the question and understanding what they're asking. So what is true about the h? The h is the output, the height, right? So h, height, is positive and increase. Let's forget about the increasing right now because there's two different things we're asking about, right? So notice positive, positive, negative, negative. In a multiple choice question, we're going to be able to get rid of two of those right away. So here is the x-axis. To be positive, we have to be above it. To be negative, we're below it. And we are talking about this part of the graph right here. Well, that's above the x-axis. So we are going to cross out negative, right? So it cannot be C or D. So now we're just asking, is it increasing or decreasing? Is the height getting taller? Is it going up? Or is the height getting smaller? Is it going down? And we know that from F to G, because we walk from left to right, we are going down. Down is decreasing, so the answer is B. Now, part 2 of this question is asking us to describe how the rate of change What should we call that? Oh yeah, the slope of h is changing on this interval, right? So what is the rate of change doing? So we're starting here and then we're going down. Like, that's actually getting smaller, right? It's becoming a bigger and bigger negative number, which means it is getting smaller. So what is going on there? It is decreasing. And we can look at this. We have this right here. Like, if you remember the visual, if we put water in that, it's going to fall out. That is concave down. So we could write this one of two different ways. We could say the slope or rate of change is decreasing, or we could call it concave down. You don't have to put both, but either one of those would be sufficient for describing how the rate of change, the slope, is changing over that interval. Go ahead and pause the video right now and give this one a shot, okay? All right, so let's look at this one. Look at our midline this time. That's that dotted line. Remember, a midline, it cuts a graph in half horizontally, okay? Notice that it's not the y, it's not the x-axis this time. So we got to be careful because this is the same type of question, right? This time we're going in between k and p. So we are going from here to here. So this little section of the graph. So the first thing, remember, we want to talk about the height. Is it positive? Is it above the x-axis? Or is it negative? Is it below the x-axis? Remember, above the y values would be positive, below the y values would be negative. I want you to take a look at all of our y values. -1, -4, -7, -4, negative. They're all negative, right? This graph never gets into the positive quadrants of the graph. So A and B cannot be the answer. So now we're just asking, what is the height doing on this guy? Well, the height is going up. If you look at the heights, right, keeps going up. So it is increasing. So C is the answer, okay? What is the rate of change? What is the slope doing here, all right? And again, if you look at this, you're going up. If your slope is increasing, then that, if we take a look at these slopes, what's going on here? We could keep going. Our slope is actually decreasing. So the slope is changing, which means we have concavity. So if we put water into that again, remember, the water is going to fall out. There's no way it's staying in there. So that is also concave down, right? So my slope is again decreasing. Or you could say concave down. All right, from here on out, we're just doing examples. So let's just go ahead and jump right in. So it says, on which of the following intervals is k negative? Where is the y value negative and decreasing, meaning going down? So we have the x-axis here. So we know that we have to be down in the bottom, right? So it could be A to B, it could be D to E, it could be E to F, right? So B to C is gone. Can't be that one, but it can be one of the other three. So those are all negative. Those other three are all negative. So now we just have to find the one that is going down, which is decreasing. So over here on A to B, what's happening to our heights? They're getting bigger. So that one's gone. D to E, hey, those are going down, so I'm not crossing out C yet. What's going on E to F? Oh, those are going up, so I'm crossing out that guy. And obviously, you could have just picked C. You didn't have to check all three of them, but that's what we got. All right, let's go ahead and read the question. I see it says, which of the following statements is true? Okay, so we're going to have to make sure that it is a correct, because sometimes this will be false. So we got to be careful. All right, so A says the rate of change is negative from A to B. This is one of those ones we're just going to go through all of them and see if they work. So A to B, our slopes look like this. That's positive. That's gone. From B to C, our slopes look like this. Those are also positive. That's gone. C is saying the rate of change or the slope is positive from D to E. Let's look. All right, so there's my, well, those slopes are negative. They said positive, so it can't be that. Process of elimination, it better be D. Let's read. The rate of change or the slope is positive from E to F. Well, E to F, well, that's going up. That looks good. So the answer is D. All right, same graph, same type of question. It's asking which of the following is true. Make sure that you're reading these carefully, okay? Because each one of these changes a little bit. So the rate of change or the slope is decreasing, getting smaller, from the interval from A to B. So here we are at A. Those are increasing, so it asked for decreasing, so A is gone. For B, it says they want to be increasing from B to C. So here we are at B. Those are actually decreasing, so it can't be B. All right. Rate of change is increasing from D to E. So we start out kind of really negative. Hey, those are increasing. So C is looking pretty good. Let's just check on D real quick. They are decreasing from E to F. Nope, those were increasing. So we were right. The answer is C. Cannot be D. All right, another different question, same graph. What can we ask? This one is actually asking about concavity. So you could do things like this. You could put the water in the bowls. That would be concave up. Where would the water fall out? The water would fall out there. All right, so that gives you some ideas on concavity. All right, so which of the following intervals is K increasing, the height? Where is the height increasing? And the graph concave down. So I like to get rid of some of my answers first. So like, where is K increasing? I'm going to go ahead and draw where it increases. So it's increasing there and it's increasing there, right? So you'll see that some of that has some blue shading, some of that has some red shading. And I want the one with red shading. So where do I have the green line with the red shading? And we see that that is in between B and C. Hey, we get away from that last graph. So we have a different graph here. We have our interval from -5 to +5. We have our function f. We want to know where is f decreasing. Remember, f is your height. Where's the height going down, right? And if I start from the left, down, well, starts, oh, I'm going up from -5 to -1, but then I have to go down and then back up. So again, I am looking for this section right here, and we are going to write it in interval notation, and that is from -1 to 2. And again, remember this, we don't really use the points, so we put those. If you wanted to put it in the other way, you could do -1 to 2, put the x in the middle, and just throw your less than signs in there. So those are the two ways that you could write that. One isn't better than the other one as far as getting the right answer. This, however, is usually how you'll see it in this class going forward, okay? All right, example 10 here. On what intervals is f, the height, both negative and increasing? Well, we got lucky on this one because there's only one section of this whole graph that is negative, so we don't have to worry about the increasing. I guess we do have to worry about the increasing. I guess the answer could be there isn't one, but I don't think they would do that to you. So where did we go? We went from -5 to -3, and we always just throw parentheses around those guys. That was pretty simple. All right, for example 11, it says on what interval is G decreasing? Where's the height going down? And where is the graph concave up? So I'm going to go ahead and do some shading for the concavity. All right. So there's my concavity. Where you hold the water, you're concave up. where you drop the water, you're concave down. All right. So I have to be in this blue section. So I want to know, where is G decreasing? And that means, where's the height going down? So starting here, because that's where we change from concave down to concave up, where am I decreasing? And I decreased it right there. Those 2 points are very important points. We'll talk about those in later ones, but those are extremely important in the world of pre-calculus and calculus. But we're not quite there yet. So what are those numbers? That looks like it is from -1 to +1. Throw some parentheses around there. Okay, on to our last question. On what intervals is the rate of change positive and decreasing? So remember, if we have a decreasing, it's concave down.